Thank you for letting me talk about the new series, Targeting Maths Problem Solving, Years 4 to 6. What I've done, I thought in my own mind, what might teachers want to know, what kind of questions might they ask you. So I'll walk you through what's in the books, why we put the books together the way that we did, and how you might talk to teachers about that. Before we say anything else though, I would like to say they're going to ask you what about all the other books in the Blake and Pascal series. And yes, they are excellent books. They will complement. They're not completely different to what we've done. So a teacher who's got one set will be able to work with our set and vice versa. So just in case they say, well, I've already got this book, how is this going to help me move on? So just so you know that. Now, one of the things that I'd like to say is every book is built on pretty much the same formula, if you like. And every book opens with a section called Understanding the Problem and Drawing the Problem. There's a reason for that. Johnny and I did a lot of research back in the late 1990s looking at why students had so much difficulty solving a problem. And what we discovered was, like a lot of teachers, they can't actually unpack a problem well enough to get started with it. We discovered at that point in time that if a student couldn't tell you what the problem was about, then they wouldn't ever solve the problem. What that meant was, if I said, oh, I caught a fish, Johnny's fish was twice as long as mine, and Jake's fish was 3 metres, which was 20 centimetres less than mine, how long was my fish? You can't say, who cares? But apart from that, students wouldn't be able to tell you that this was a problem about fishing and having a discussion about who caught the longest fish or whatever. We also found that teachers would often say, we'd hear them saying to students, go and read the problem again. Well, if you didn't understand it the first time, you won't understand it the second time. Marion Walters, who's the world's guru on problem posing, actually says about 60% of problem solving time should be spent in the problem posing phase. And I guess this is one of the biggest differences between what we're doing in this series and what Blake and Pascal have done in the other series. We're actually beginning every unit, and the students are expected to use the process of understanding the problem, every single problem that they do. So basically, we're showing them how to highlight the important information, how to answer the question, what's the problem about, how to then say, what will the answer tell me? Because again, students work on the problem, then think about the problem, then they work on the problem, but they don't actually stop and say, well, what's the answer going to tell me? How will I know if I've got the answer right or if it's reasonable if I haven't posed that question in the first place? In Singapore, during the problem posing stage, students are asked to write a grammatically correct sentence with a kind of a closed passage in it. So the answer will be however many elephants. So we're encouraging students to do the same, write their sentence with a gap so they can fill in the missing parts at the end. So by the time they've worked on Unit 1, whether that's Year 4, 5, 6 or 7, they should actually have a really good grasp of how to unpack a problem. Now, one of the things that this is going to do too is improve teachers' ability to do that part of the problem solving. Okay, so having said that, one of the things that sets our problems apart from some other people's problems probably is we do try and make them totally engaging to students. We try and come up with contexts that are going to make them say, oh, I've experienced that, or oh, I can imagine that. And in fact, the Dutch, who are really good at numeracy, have a word, and the word means realism, can project yourself into the problem. It doesn't mean real world, but the kids can go, oh yeah, I can imagine, I've been to the show, I know how this bit works. So we're providing that kind of realism and context that should be engaging to students. So I suppose that's the first part. Where we're very similar to all of the other ones is we've taken most of the most common problem-solving strategies and we've gone through them. So in order, and I'll just read this so I can get them in the right order. Unit 1 is understand and draw the problem. Unit 2, identify the steps and choose an operation. One of the things when you look at, say for instance, NAPLAN results that you notice is wherever the students have to choose an operation, they struggle. And that's about 30% of the questions that some students get wrong because they can't identify what the important steps are and what the operation is. So we've chosen that as our second most important strategy after understanding the problem, so that the students can do that part. Then we come to make a model. That's a very common one. And in with that, we've put guess, check and improve. In most earlier problem-solving books, the focus was on guess and check. What we now know from the research is if we don't ask the students to stop, look at what is working and what isn't working and where it might have gone wrong and how they can fix it up, then they just scrap all the work that they've done or they give up. They don't build on what they've already done. So we've just gone one extra step further with the guess, check and improve. Otherwise, most teachers would be familiar with that strategy. We've then come to make an organised list and working systematically. Again, those are two of those top 10 problem-solving strategies that are covered in most problem-solving books. We've then come back, and you might say, well, why have you done that? Why have you come back to drawing a picture or a diagram? And basically, in the first unit, we were just hoping that students might draw a picture to help them understand what the problem is about. They may not actually have to use that picture to solve the problem. Whereas when we come to draw a picture, draw a diagram, then that is the solution strategy that is required to solve that particular problem. So the kind of diagrams, it might be Venn diagrams, might be the Singapore bar model, might be an empty number line, might be maps, might be grids. So there's a whole range of different diagrams that can be used in there. Then we come to draw a table. Now, over the last couple of years on NAPLAN, more and more questions have either presented information in tabular form or have required the kids to complete some sort of table or create a table in their mind. And again, it's one of those areas that the kids do really poorly on in NAPLAN. So I guess one of the things that we are doing is being responsive to the areas that we know kids and teachers are struggling with. And I guess that's also why we've given a whole chapter to draw a table, rather than putting it in with some other things. Then we have work backwards. For most people, that's the most difficult problem-solving strategy. They don't know where to start from. They don't necessarily understand the inverse operation. If I've just done addition followed by multiplication, I've got to backtrack with a division and a subtraction to get back to that starting point. And so that's a whole another mathematical skill all on its own. And also in there we've put try a simpler case. And I guess in my mind it would be nice to have try a simpler case all the way through, because one of the things we can always say is if the problem is too hard, what can I do? I can make it simpler. I can use smaller numbers, I can use simpler diagrams, whatever it is I can do to make this now manageable for me is a really important strategy. Now when it gets to year 6, there is a slight difference in that sequence, because the last unit in the year 6 book is actually algebraic thinking. So during year 6, the curriculum is moving students towards understanding the pronumeral, definitely working with patterns. And so what we've done is we've actually created some situations where it would be quite easy to what's called algebraify the solution. So instead of saying 6 blue pens, we can go 6B, or just dropping in a pronumeral instead of having to write the whole word. Okay, making it manageable, bite-sized. We're not doing linear equations or anything like that, just very simple, basic algebraic thinking. So I think that's pretty much the unit. Now, other things that we've done, we've written investigations, so there's an investigation for each of the units in the book, the 8 units. So there are 8 longer-term investigations, and they're situated at the back of the book. Now, I hope that when you talk to teachers, you will say, don't wait and do all of those investigations at the end. There's one for every unit. So if I were the classroom teacher, I'd be taking the investigation that matches the unit and running that at the end of the unit. It's not the law, you don't have to do that, but that's how I would use those. You'll also find that there are revision questions. So at the end of every second unit, there's a set of revision questions for the 2 units that preceded it. Again, you can use those there. You could decide to split them up and use them at the beginning. You know, I'm going to use one at the end of each unit rather than do 2 together at the end of 2 units. I might decide to save them until the end of term because I'm reporting and that's what I want to do. So it's not totally fixed in sign. There is some flexibility there. Obviously, there are solutions. So what we've tried to do is make the solutions fairly clear, matching the strategies that have been used in the units. But we also need to understand, and teachers need to understand, that's not the only way, and students may come up with some other methods that are equally valid. What we've done is given them the ones that are most predictable and most closely related to what we've been teaching. I don't know whether I've missed anything. Johnny, anything you want to say? Johnny's here with me.
You've done a wonderful job, Anne. That's wonderful.
Okay, he thinks that's okay. So I'm going to stop there. And I hope you have a great conference.